Hi there, my name is Roger Williams, and we're going to go over some informatics visualizations, cheminformatics and pharmacy informatics. This is for the iConnecto Deep Dive for Gold Standard Elsevier. Now, modern medicine can be considered to be an information business at its heart. Procedures and chemical products are central to medicine, but every step depends on information processing of diagnostics, relevant literature, clinical studies, and much more. This short presentation will review some example cheminformatics and pharmacy informatics visualizations using the newer technology infrastructures, Web 2.0 and the semantic web. It will also show some updated demos from a proposal submitted to the Elsevier Grand Challenge 2008. Okay, first some Web 2.0 artifacts. The industry is already fully in the Web 2.0 wave, as popularized by various social networking, information sharing, collaboration, and user-centered design, sites, and technology. It's interesting that although the primary distinguishing characteristic delineating Web 1.0 and Web 2.0 is user interaction, according to Wikipedia, the iconic Web 2.0 tool is a visualization, usually driven, of course, by user commands to a corpus of documents or pictures. This iconic tool is the ubiquitous tag cloud, and here's an example. Now, this cloud is actually just a graphic where the points of the graphic are words from a set of documents, and their font size is proportional to their frequency in the corpus. This is basically another type of bar chart of word frequencies. It gives the user some rough idea of the frequency of concepts in the corpus. So let's apply this to a different corpus. Now, if the same process, word frequencies bar chart, is applied to a corpus of pharmacy informatics documents, such as this biological toxins, poisonous arthropods. Let's see what we get here. Yep. Black widow spider, black recluse spider, a lot of nice guys. You have the same capability applied to a more useful to medicine corpus. So first I'm going to define the stop words. We don't want these words to appear in our cloud. And then we'll run a word frequencies that takes that document, and as each word is used, the font gets bigger and bigger. So this is within a single document. But you can see bite is used the most, and muscle and fasciculation. And there was another one here. Oh, and venomation. Very, I'm sure, intense words when you're bitten by one of those nice guys. So let's talk about Web 3.0, artifacts of Web 3.0. This term is significantly less well defined, but most people agree that one component of this is the so-called semantic web, where metadata is ubiquitous, making possible computation of huge volumes of data being collected and stored. These computations should enable actionable conclusions to be drawn from the data. A very simple example is that today you cannot Google this following question. How many cortisone bottles were shipped on the same days in 2008 as it rained in Columbus, Ohio? You can't Google that because it isn't found on web pages out on the web. Now, of course, this is a contrived question, but when the metadata is connected to the data, you can begin to answer questions of this form, which are much more relevant and much less contrived. So let's apply this. So this time, a different corpus. This time our corpus will be a database of pharmaceutical chemical compounds and a search engine interface to a group of documents. Rather than, or in addition to keyword search, you can browse the compound seeing the IUPAC name and the number of documents in the corpus which contain this name. So obviously this type of interface is more powerful than keyword search alone. So we'll browse the chemical class of sulfides, and you can see there's ethylene sulfide, propylene sulfide, diethyl sulfide, dimethyl disulfide, and one of them doesn't have a plot. And just to show you that this is live, I'll go to a different class of chemicals, esters, I think, right? Let's try this. And you can see that methylformate has 113 documents in our corpus. Methyl acetate has 36 documents in our corpus. Methyl acrylate has 91 documents in our corpus. So obviously, this gives you sort of a better browsing interface. Now let's talk about a primitive gaming interface. Let's look at another metadata-enabled interface between a pharmaceutical drug, acetaminophen, some component chemicals, and a back-end web-enabled information store. Now this display graphic shows tooltips of additional chemicals which, when clicked, bring up more information about the selected chemical. Further, it allows me to rotate it and still get the information I need. So the information is embedded in the graphic. So let's run this. And here's acetaminophen. I'll make it bigger so you can see it. So here it is. And if I put my mouse over some of the chemicals, I have a tooltip that some data is connected to it. Now this is an acetaminophen molecule. One of the components, some of the chemical components of it is not formamide, or it's not, let's see here, titanium 2 hydride. But the list of chemicals, we can take some other list and connect it to this graphic or some other graphic. Now the reason why I call this a game is because I can click on it and it'll bring up more information about this chemical. So look at this. We're going out here to get a whole bunch of information: molecular weight, the density, the CAS number, the pub chem ID, the auto ignition point, the NFPA label. So you can see there's a lot of data behind this. Now another reason why I call this a game is that I can actually rotate this and the tooltips are still valid. Propylene, isotactic, metaboric acid. So I can still click on this. So you can see this is kind of like a game type interface. Obviously very powerful. Now, a drug interaction graph. There's plenty of news about medical mistakes around drug interactions. Here's a graph between Prevacid, oxycodone, and Lipitor, another contrived example. I would hope no one would take all of those. And this shows the common interaction drugs. So it's obviously got very small font. There's a lot of data here, so I'll open this up so you can see it more clearly. Look at this. This is really cool. So oxycodone has its own set of things, centraline, that it's interacting with. But if we look at this graph, let's make it even bigger. I got to fix the font sizes. I think atorvastatin is Lipitor and lansoprazole is Prevacid. So it has 3 drugs that are common. So this gives a little bit more information about the interacting drugs between Prevacid, oxycodone, and Lipitor. Okay, so what have we covered? The Web 2.0 tools applied to a pharmacy corpus, an alternative browsing interface to a database of chemical compounds, a primitive game hooking chemical interactions to a web-enabled back-end database, and a graphic showing interactions among common pharmaceutical products. So thanks for listening, and I hope you enjoyed it.